Hello friends, in this session we are going to see anonymous inner class in Java. Say I have a class A, B, C and I have int x is a variable here which is having say 99 and I have a void show method in this and it's printing show method in ABC, right? So this is one normal class, and I will create an object of ABC, say A1 is equal to new ABC, and this is to give a termination, right? This is object creation. But just before giving a termination here, if you give a parenthesis here, then this becomes a anonymous inner class, right? So this is a anonymous inner class. Now when you will write like this new ABC of this, it creates an object. Actually this is an anonymous inner class and it gets an object of type anonymous inner class, and that object address is stored into A1, and this anonymous inner class becomes a subclass of ABC, and subclass object is created and stored into A1. So this complete becomes a dynamic dispatch, right? A1 is a reference variable of super type and which contains an object of subtype. Subtype is nothing but which is an anonymous inner class. So in this case, when you compile this program, say test1, you get a dot class file of test1, you get a dot class file of ABC, and you also get a dot class file of this is anonymous inner class. But what will be the dot class file name for this? The dot class file name for anonymous inner class in this case will be test1 $1 is the dot class file name for this anonymous inner class, right? And if I take another, say ABC A2 is equal to again new ABC, and it is this, then again this becomes another anonymous inner class, and this is again a subclass of class ABC, and again it gets an object of type ABC, anonymous type, and that also going to store into ABC. Again this also becomes a dynamic dispatch, and it is super type reference variable and subtype object. Now this is dot class file name again test1 $2, so it becomes like this dot class file name. It is test2 dot class, and this is also one dot class, right? So this is 2 dot class file is generated in your workspace. Actually not 2, test1 1 dot class file with the name test1 dot class. For this anonymous class it is test1 $1 dot class. For this anonymous class test2 $2 dot class, and so suppose you have some other class, say class XYZ, and again if you create a anonymous inner class for this also, then this is ABC, not ABC actually, XYZ, say X is equal to new XYZ of this is another anonymous inner class. So for this dot class file name should be again test1 $1 dot class. Sorry, not 1 dot class, it is 3 dot class, right? So this is the dot class file name for this, and this is the again this is the subtype of XYZ. This one is subtype of XYZ, and the object which is going to be created here, it is subtype object and going to store into XYZ super type reference variable. So this again also becomes a dynamic dispatch, right? And the class you can say is like this, you can say it is XYZ, again say x2 is new XYZ, and this, right? So here you can declare some members, right? So anonymous inner class is from here and till this is the anonymous inner class. So I'll not do this with here, I'll do it with say ABC. So I'll create one more object here. This is ABC, say A3 is new ABC with this, right? So this is a anonymous inner class, and which is a subtype of ABC, right? Anonymous inner class. Now you can say that when you are normally writing like this, say ABC A4 is equal to new ABC, right? So this is just object creation, it is not anonymous class. But this complete, you can say it is an expression like this, and I write say int x is equal to 10 plus 2 plus 5 multiplication of something like this, and I write. this complete is one expression, and the expression has to be evaluated and result should be stored into X, right? Complete expression should be evaluated first, and after evaluating this complete expression, whatever result is coming, that result should be stored into X. Same way, this new ABC constructor call is also an expression, and after evaluating this expression, the result of this expression is going to store into A4, and the result is nothing but an object address. Object address is going to store into A4, right? It is a reference variable. Same way, when you write a new ABC of an anonymous class like this, then this complete you can consider as an expression, and when this complete expression gets evaluated, you can get an object. It is going to get an object of type anonymous class, which is subtype of ABC, and that subtype object is going to be created and is going to store into A3, right? Now here, if I want to just print the A3, if I just print here A3, then it has to give the class name at the @ symbol some hexadecimal value, because toString function is not overridden at this point. So here it is to give class name, and the class name should be here test1 some numeric values and dot class, then at the @ symbol some hexadecimal value it should print, and it will give actually the fully qualified name. So it is test1 $4 at the @ symbol some hexadecimal value. So test1 $4 is the class name, anonymous class name. So till this is 3 is done, so here it is getting test1 $4 of the class name for this anonymous class, right? So this is the anonymous class, and when this complete expression gets evaluated, it gets an object automatically, and the object address is going to store into A3. Importantly, you have to remember that this anonymous class is the subclass of ABC, where in other inner class concept like static inner class and instance inner class or local inner class we have already seen in some sessions, and those inner classes actually are not the subtype of, those will not be subtype of ABC. Instance inner class or static inner class or local inner class are not in inheritance relationship with this class, but anonymous inner class is always with an inheritance relationship. And when you say like this new ABC and this, it is actually the subtype of ABC, and subtype object is going to be created. When you completely evaluate this expression, it gets an object of subtype, and that is going to store into A3. So it becomes a dynamic dispatch. Now next is, what are the members can I define in this? First is, if this is a subtype, then I can, all the members of this ABC, right? All the members of ABC is inherited at this point. So here I can say if this is say A3, I'm printing okay, and after that I'll print A3.x, which is also right, A3.x is also inherited. So the x value which is here hardcodable 99, for this also the x value should be 99. Just run it at chunk once and it is 99. Okay, fine. Next, if I say A3.show method, which is again inherited in this anonymous class, so it will verify here in A3, when you will say new A3.show function, when you will call, then inherited show function which is here is actually going to call, and the implementation is remains same because you are not overriding. So it gives the output here show in ABC. You run it and check, it is this show in ABC. But what I can do is I can override it here. I can say again void show, and this is say show function in anonymous inner class, right? Now when I'll call A3.show, what it will do, because it is a dynamic dispatch, right? Super type reference variable and subtype object. So when you will say here A.show, show function signature is going to verify in reference type, and reference type is ABC. Means in ABC class it is going to verify that show function signature is available or not. Okay, it is available. If it is available, then it is going to call from the object type, and object type is anonymous type. So here it is going to print, going to call, when you will say here now A3.show, it is going to call from the anonymous class, and now the output should be show in anonymous inner class, and run it, it is show from anonymous inner class, right? So the method which is inherited, this is actually overridden method. Okay, this is an overridden method in anonymous inner class. Next, what are the other members can I define anonymous in a class is if I try to declare a new instance variables, say it is not this type, it is the string type, str is equal to say hi, right? Can I define that or not? Okay, it is perfectly absolutely fine. You can define a instance variables. If I define a static variable, say here static, and say string msg is equal to hello, not okay, it is a compilation fail. You cannot declare a static variable inside the anonymous in a class, so this is not okay. This cannot be done. A static variable cannot be defined inside the instance in a class. Okay, if I try a instance block, so I'll say it is instance initialization block in anonymous in a class, it is fine, right? It is compiled successfully fine. Now when you are creating an object, here you are creating an object, and instance block should be executed at the time of creating the object for initialization. Now if you run this program, you have to get the output of instance block is executed, and then you have to get a3 you have to get, and then you have to get a3.x, and you have to say a3.show, right? You run this and see it is instance initialization block in anonymous in a class. So you can define instance initialization block in this. Now if I define a static block, say one static block, and inside this I'll say it is a static initialization block in anonymous in a class, it is not okay, it is compilation fail, because you cannot declare any static member. Means you can say here you cannot declare any static member inside the anonymous class. Why it is so? Because the static member of a class should be accessed with the class name directly, not with an object reference. But this class is not having any name at all. Then how you can define a anonymous? How you can define a static member? Because how will you call that? Right? Because the class is not having any name. So a static member you cannot define inside the anonymous in a class. But okay, if I try a new method with this, void disp is a method which is instance, and I'm saying here okay, it is disp method in anonymous in a class, it is perfectly fine, right? It is perfectly fine. In this method, you can instance method can be defined. Next, if I try to declare a static method, say static void m is a method, and this again you cannot define any static member in this, right? So a static member cannot be defined. Next, if I try to define a constructor for this anonymous class, then how will you define the constructor? And constructor declaration rule, we have seen constructor name must be same as class name, and this anonymous class means it is not having any name at all, so you cannot define a constructor in anonymous in a class also. Means you cannot define a static variable, you cannot define a static block, you cannot define a static method, and you cannot declare a constructor also in anonymous in a class. But you can declare an instance variable, you can declare an instance block, you can declare a new instance method also. But the problem is, suppose we have seen this is a dynamic dispatch, and we have already seen in some session in dynamic dispatch how the method will be called, how instance method will be called in dynamic dispatch, how static method is going to be called in dynamic dispatch, and how instance variables are going to be called in dynamic dispatch, and how static variables are going to be called in dynamic dispatch. So for example, if I have a class like this, what is dynamic dispatch here is, say I have a you have a class A and you have a class B. B extends A, right? B extends A, and A you have a variable int x is equal to 99, which is instance. You have a static variable, and y is say 8, right? And now say it has some other members also, and it has a method void show method, and which is the instance method actually. So I'll write here SOP statement. This is show method in a class, right? And you have a static method also, static void and disp method, disp. And inside disp also I'll write one SOP statement. I'll say it is disp method in a class, right? Disp method in a class. So this is the members in class A. You have again another class, say class B, and B extends A, right? B extends A. In this also I have two variable, int I is equal to say 10 and one static int j is equal to say 20. And I'm overriding both these two methods, so I'm right here void show method, and show method is having one SOP statement, and it is show method in B and void. This is static method overriding, so it should be a static only, and void disp method. And here if I write a SOP statement of disp function in B, right? This two class. Now if I create an object of A1 is equal to new B, super type reference variable and subclass object. So this is called as dynamic dispatch. This is dynamic dispatch, super type reference variable and subtype object. But now if I say here, when you are creating an object, actually it creates an object memory for I and it allocates the memory for X also, because two instance variables are there. So this is A1 reference variable and it points to this object. Memory for X is allocated, this is 99, and memory for I is also allocated, this is say 10. This address is 1040 and it points here, right? Now when I'll call, say in this SOP statement of A1 dot X, from where it is going to call a variable, right? A variable is going to be called, or assume these two variable name is not different, it is same. This is also I and this is also J, it is not different, same. Here is I, here is I. So 2I memory is allocated at this point, 2I. And class A is loaded, there is one J, and class B is also loaded, there is also one J. This I and J both is accessible in class B because it has extend class A, right? And here in this object now I have 2I. Now when I'll write here A1 dot I, when I'll write A1 dot I, which I it has to access. So instance variable execution in dynamic dispatch, instance variable access in dynamic dispatch, you have seen that always should be accessed from a reference type, not from the object type. Variable is always going to access from the reference type. So in reference type you have reference is A1 and which is of type A, and here I is there, that I value is 99. So this is 99 and it is going to print 99 because it is accessing from the reference type, right? So instance variable in dynamic dispatch always access from the reference type. Now instance method, if I say here A1 dot show, this is instance method call. Now A1 dot show, and I will say instance method show is overridden here, and it is a there also in super type also you have a show. Now which show is going to be called when the reference variable is super type and the object is subtype, or when it is dynamic dispatch. So in this case what JVM will do is, when you will call show function here, it will check the show function which you are calling is available in reference type or not, signature. Just it verifies the signature of show function is available in reference type or not. Now in reference type show function is available, right? And it calls the show function from the object type, means here it is going to print show in B. So this is the output should be show in B function. You have to be noticed there, you have to notice this very clearly, that when you call an instance variable where superclass instance variable and subclass instance variable name is same, and when you are using dynamic dispatch, then the variable always calls from the reference type, which is from A, means from super type, and the functions signature will be verified in reference type, and function will be called from the object type. So when we'll say here a.show, show function is going to verify in A class show is there or not. Okay, show is there. Then it calls the show function from B, this output, right? But when it is a variable directly calls from this place. Now if I write it like this, say SOP statement of A1, say it is A1 dot something, some K, right, K, and assume K is available here. One int K is there, and the K value is something like this. Now here when I'll K A1 dot K, then K should be accessed from the reference type, but in reference type K is not available. So at this point it gets a compilation error. It says that K is not defined, cannot find symbol K, right? Because in dynamic dispatch variable always should be accessed from the reference type, and in reference type this K is not available. So you can say here in dynamic dispatch newly defined variable in subclass cannot be accessed by using this reference type. Same way, when you have a newly method declaration here, say I have a method here m, and this is m. It is a newly defined method m in object type, right? Now if I say here it is a1 dot m, say I'm telling here a1 dot m should be called, and m is actually a newly defined function in this place, right? This is a newly defined function in this. So if I say here a1 dot m, right, a1 dot m, and this m signature should be verified in reference type, and in reference type no function is there with this signature, so no chance to call from the object type. So here only it gives an exception, and it says again cannot find symbol m is not available, right? So this is how instance variables and instance method calls in dynamic dispatch. But what about static members? Static members, say in this y is there, and in this j is also, sorry, not y, it is j, and this is also j. Now in this dynamic dispatch, if I say a1 dot j, then from where it is going to call in SOP statement, if I write like this, say SOP statement of a1 dot j, then because this a1 is a static member, in dynamic dispatch it is not going to work in that way, because this is going to replace it the class name a dot j at the time of compilation itself. So this is no checking, nothing, it directly calls it from the super type, means from the reference type. Same way, if I have a static method, say disp method, here I have overridden already, and if I say a1 dot disp, if I say here a1 dot disp, then again this is also going to be converted to class name at the time of compilation. Say it writes here a dot disp, actually in your source code it gets compiled, it gets transferred at the time of compilation. So this static member also is not going to call from the subtype or object type, it is going to call from the reference type, right? Going to call from the reference type. So any static member are actually not going to work dynamically in case of dynamic dispatch. But here you have to notice instance variable and instance method, how it is going to call. Instance variables are always going to call from the reference type, so newly defined instance member in subclass or object type cannot be accessed in dynamic dispatch. Next, the method which you are going to call in dynamic dispatch, the method signature will be verified in reference type, and method will be called from the object type. So newly defined method which you will define in subtype is not going to call in dynamic dispatch, because it will give a compilation fail and it will say it is not available in reference type, right? Now come back to the anonymous inner class again. So this is, in this what we are doing is, static member we cannot define anything, okay, fine. This also we cannot define. and disp is a newly defined method, or I'll take a newly defined variable here, str, right? Str is a newly defined method which is having high. Now if I want to call this newly defined method at this point, sorry, newly defined variable here, if I say a3 dot str, it is going to give an error because str is going to verify in reference type, and in reference type str is not available because the reference type is actually ABC type, and the object which is created here, it is of subtype, right? It is of subtype, so this is not possible, you cannot call. Now if I have a newly defined method, I have a newly defined method here, disp, and if I try to call disp also here, a3 dot disp, then this is also not going to be called because the signature is going to verify in reference type, and in reference type there is no function with the name disp, so this also cannot be called. Then why it is allowed, then why it is allowing here in the anonymous in a class, we can declare instance variables, we can declare instance block. Okay, instance block is going to execute at the time of loading the class itself automatically, but what about the instance variables and instance method, which actually we cannot call from outside? So what I can do here is, when I'll override the show function, inside the show function only I'll access here, it is say str, and I'm printing here str, right? Then it is accessible at this point, or inside this only I can call here, say it is disp function directly, right? Now I'm not using dynamic dispatch. The show method, which is already overridden, inside the show method only I'm trying to access str, and I'm trying to access disp, so this is fine, it is going to call. And from outside now I have to call show method. Show method can be called because show method signature is available in reference type and it is overridden, so it is going to call from the object type, so this show method is going to be called. And show method is printing show in anonymous in a class, and str, which is newly defined at this point, and it is having disp also, right? It is calling disp also, so this is fine. Now you run show function is going to be called and everything is fine, right? Show function is called, inside the show you're calling str, and disp is also calling from str, right? It is calling in this way, this is okay. But assume I'm not overriding any function and I want to call, right? But here one more point you remember very clearly, again I want to remind that this is a class, right? This is anonymous in a class, and this complete is one expression, right? And when you are going to evaluate this complete expression, you are going to get an object of type a1, subtype object, and that subtype object is going to store into ABC reference variables. Same way you can say from here till this is a complete one expression, and when this expression evaluates, it is going to get an object of type of subtype, and that object is going to store into this a3 reference variable. But the problem what we are facing here is the disp is a newly defined method, and this is also a newly defined method. Now if I am not overriding any existing method from the inherited class, then newly defined method is not possible to call. So what I can do here is, now say I have a anonymous class for ABC a5 is equal to new ABC, and this is the anonymous class, right? This is anonymous class here, and in this I have a say one newly defined variable int I is equal to 101, and new disp is a method I want to call, right? Now if I print this, say disp in anonymous in a class, now the class is defined, but I cannot use this member since I am not overriding any of the inherited method. So newly defined method is not possible to call at this point, and all these things I'll cut from here and I'll put before that, right? So newly defined method I cannot call, and this complete is actually one expression. So what I can do is, we have already seen somewhere that I can call a method dynamically like this, say new ABC dot show, I can call directly. What we are doing here is actually this is one expression, and when I'm evaluating this expression I'm getting an object of ABC. That ABC object reference is not stored anywhere. If I instead of doing that, what I can do is say ABC A6 new ABC, and this is A6 dot show function, right? A6 dot show function. Here what we did, this object is created first, object address is stored somewhere in a reference variable, and then we are calling show on that reference variable. And in this what we are doing, we are creating an object and reference variable is not stored. After creating the object, immediately we are calling show here, immediately we are calling show. Now this complete becomes one expression, and when this complete expression gets evaluated, say till this is evaluating first, you got an object, and this part of evaluation is over. On that object, immediately you are calling show, and when you will call show, this complete becomes one on one expression, and when this expression gets evaluated, this show is returning a void. It is returning a void. So this void you cannot store here anywhere, and you cannot say here it is ABC of A7. It is incompatible type, because now when this complete expression gets evaluated, you are not getting anything, you are actually getting a void. So this complete expression evaluation result is void, and void cannot be stored into ABC. Right? Void cannot be stored into ABC. Because of that, it is giving a compilation fail and is saying it is incompatible type. But what I will do is, if this return type is ABC, and if I return this from here, return this, means current object has to be returned. Now this complete expression, when it will evaluate, after evaluating it is getting here this current object, means this object address again is going to be stored into this reference variable. Same way, if this function return type is int, and then it is returning here 99, then after complete expression evaluation, this is going to get a integer type, say this is x, and x is going to get a 99. X is already defined, so it is k. Now it is fine. So this is object creation and function call immediately. It is not storing the reference anywhere. Before that only it is calling the object directly. So this is a complete expression evaluation. Now what I will do is I will make it void only, and I will not give any return type here. No return type in this. So this gives an exception, it is not valid. So in this is fine. Right? So the same thing I am going to apply with this anonymous class. Till this complete evaluation, this complete is an expression, and after evaluating this complete expression, you are going to get an object of type anonymous in a class. And in this we cannot call a5 dot show, sorry, disp, because disp is the super type reference variable, and which is not having disp signature, right? So what I'll do is, like this only, when I'll create this new method inside this anonymous class, and after creating that object, I will not store the reference variable anywhere, and immediately after creating the object, immediately dot disp, I'll go here directly dot disp. This function is called here directly. Right, so now it is not dynamic dispatch. But what is the problem here? The problem is now this complete becomes one expression, and after evaluating this expression, disp function is returning a void. Similar like this show function, after complete evaluation of this expression, this is returning a void, and that void I cannot actually store in this, say, ABC A7 incompatible type. But if the show function is returning an integer value, then this I cannot store into, this I can store into that integer type, right? Or if show function is returning a this, then this statement is valid. So in this case what I can do is, what I will do is, this complete expression evaluation is done, and how here we are not storing the result anywhere, so this also I will not store anywhere. So newly defined method is fine now, because this disp is returning a void, and the void I cannot store anywhere. And inside this only I'll print I also, I, and this is I, right? Now if you run this and it is working fine, this put in comment, and here you draw a line, and run it. It is fine. Disp is called and I value is printed. So newly defined method in anonymous inner class, if you have a requirement to define a new method, then in anonymous inner class what you can do is you can just define it and directly call the function and don't store the address anywhere. The same way, again what I can do is I'll write again a new ABC, and inside that I'll take a method, say some m method, and m method return type is now int, suppose. Then I'll print here it is m function in anonymous in the class, and I have a new method also, the variable also here, say it is j, and j value is 99, so I'll print here j also. It is j and j is plus j, right? And after because the m method signature is not available in class ABC, and it is not going to be dynamic dispatch, so I'll call here directly m, but m is supposed to return a integer value, so I'll say here it is return something, say 9999 something. Now if you see this complete expression, this is a complete expression now, or from here it is complete. One object is created, new ABC object is created, not new ABC, anonymous class, till this the object is created, and after creating that object you are immediately calling m function, and when it evaluates the m function also completely, it gets a result which is 99. So here the return type should be, say int result is equal to. Now this complete is fine. After complete expression evaluation, you are going to get a result of type int, and that int type is stored here. And after that, if you print here, say it is result is, and it is to print 999. Before that you are calling here m function, okay, m is called, j will also 999 printing, and result is also printing. Run it, it is absolutely fine. Or if I take it something like this, say new ABC, and this is the anonymous class, and inside the anonymous class I'll have a method, say void so disp is a newly defined method, and I'll write here it is disp function in anonymous in a class, and it has some string, msg is a hello guys, right? This is the string, and string also I want to use, and actually it is not inside the message, I'll take it as a instance variable inside the anonymous class. So here I want to print that msg, so I'm printing here it is msg, right? Now assume this method return type is not void type, it is object type, right? And then this method has to return something, and I'll say it is return this, means current object, and current object of course is of type anonymous type. And this object, if I want to store here, this is object obj is equal to this file. So this is anonymous inner type, and the function is called, and after calling the function you are getting the current object, and current object is stored into object type, right? Object type is again super type, it becomes dynamic dispatch. So returning this, but the function has to be called, so I'm calling here function disp, right? The function is called, and after that again if I print here that obj, and then obj should be the anonymous class name at the red symbol, some hexadecimal value, because toString is not already done, so this is the object, right? Or if I write it like this, another one, new ABC, and return type is, I have a method get instance method, and this returns just this, and this is going to, so the return type I'll consider here object type, because I don't know what is, or I'll just say it is ABC type, okay, and it is returning this. And after that you are saying here get instance, and that instance is of type ABC, so I'll write here ABC A8 is equal to. So newly defined method you have declared here, you have defined a newly method, and after performing all the operations you are going to get the same object also, right? Same object also, and it is stored in A8, and you'll say here it is current object is returned, and stored in A8, say A8, and then I'm printing here it is A8, right? A8. And now you run this, it is newly defined method, object current object is returned and stored in A8 and printing A8. So newly defined method in anonymous class you can create in this way, and you can call, but it has to be called immediately once the object is created. Till this, now till this is the expression, and after completing this expression expression evaluation, you're going to get a current object, because this method is having return type as this, and the method is called, and the current object is stored into this, right? But what about if it is having two newly defined method, right? So if I write it, say new ABC, and I have a method void m1 in this, and it has m1 in anonymous in a class, and I have one more method void m2, and m2 is also having m2 in anonymous in a class, right? And here if I want to call dynamically, I can call one method. I cannot call two methods, right? And no chance to call two method. So in this case what I can do is, I'll tell this return type is ABC, and it has to return this, and here first I'll call m2 function, and on that, when till this is done, when till this complete expression is evaluated, what will you get? You will get a this means current object. On that current object, immediately here we call m1, right? M1. Okay, it is because ABC type again, so it has to be it is not possible in this way, because again it is becoming dynamic dispatch, right? So what you have to do is, this type, if I say, it will be of super type, so keep it as void only, and this you don't call here, you call here m1. Okay, right. Now when you are calling here, this complete expression is evaluated, and after evaluating, or say it is void, so not returning anything, and this complete expression evaluation is still this, you're going to get the object, and on that object immediately you're calling m2, and when you call m2 will call m1, and m1 is actually here, it is this dot m1, on the current object only it is calling m1, so the output should be m1 in anonymous in a class, and m2 is anonymous in a class, right? And it is this, right? So like this. Or now if m2 is returning something also, you can say return this, and the return type of this is, say, ABC, and ABC is stored, ABC A10 is equal to this, right? So that is also valid, because after completing that complete evaluation, you are going to get an object of type anonymous in a class, and that is stored into A10. So newly defined method in anonymous in a class, you can call in, you can get in this way, or you can call it in this way, or you can get the object also, right? So this is anonymous in a class. But when I have to use anonymous in a class, so assume I have a interface. I have an interface in, and in that I have a method void show method, which is by default public and abstract, right? Now if I want to implement this method, what we are doing before is, I'm creating a class A, and which implements in, right? And I have to override the show method here as public void and show method should be overridden, and here I'll write it is show method in a class, right? Show method in a class. Now if I want to call this method from the main method, then I have to create in is equal to new a object is created. Now again it becomes dynamic dispatch, because in is the super type for a and object is of type a. Now in this, if I call in1, say this is in dot show function is called. Now how it will call this show function? Show function signature is going to verify in reference type, means it is in interface, and in interface show function is available. Then show function is going to call from the object type, means it is going to call from a. So here the output should be show in a. This we have discussed in interface, right? In interface how it works. Now the same operation, instead of writing this complete evaluation, what you can do is you can write anonymous in a class in1 is equal to new in. Interface we cannot create an object, right? But it is not an interface object, it is an anonymous class object. So this is the anonymous class you have designed for the interface. It is a subclass similar like this. It is becoming a subclass similar like this, but this class is having a name which is a, and this class is not having any name. Now it is anonymous class, but it has the abstract method which is inherited from the interface, that is show method, and show method should be overridden here, and you have to say public void show, right? And you can say here it is show method in anonymous in a class, right? Show method in anonymous in a class. Now at this point you can call it in1 dot show, right? And now run it, show in anonymous in a class, right? This is the use of inner class. When an interface is having some method, you have to implement the interface separately somewhere, and you have to call the function. But instead of doing that separately, you take an anonymous class, and in that you give the implementation of all the abstract method of the interface and call the function. You notice here this object is not of type interface, object is of type anonymous in a class, right? Same way in multi-threading, when I'm having something like this, say I have a class, this is my thread, and inside the my thread actually implements runnable interface, right? Runnable interface, and it has a run method, and run method should be overridden, and you have to give the implementation of the run method. And the implementation what I am giving here is first it should get the current thread, th is equal to thread dot current thread, right? And I'll write a for loop here, int I is equal to 0, I less than 10, and I plus plus. And inside this it has to print it has to print I value plus give one tab space plus th dot get name, okay? I value and thread name is to print for 10 times, but it has to go to a sleep state for some time, so I'll write here try and catch, and in try I'll write, and in catch I'm writing e dot print stack trace, and in try it is thread dot sleep for say 500 milliseconds, right? This is the implementation of runnable interface. It is not a thread object. So if you want to create a thread object from this, what you have to do is, I'll write it here and I'll draw a line first, and in this you have to create a runnable object first, which is my thread, my th is equal to new my thread. It is not a thread object, so you cannot start execution of this. So what you can do is create a thread object and create a thread object th is equal to new thread by giving this my thread as an argument. So runnable is an interface which is having one abstract method which is run, and your class is implementing this runnable interface and overriding the run method because it is abstract, and giving the implementation in this and doing all the operations, right? Now runnable, when you will create an object of runnable type, it will not be an thread object. So by providing that, you have to create here a new thread object, and then you say thread dot start, right? Thread dot start. Now the thread will start execution. Now if you see this output, thread is executing, thread 0 1 2, something like this. 10 times it has to continue. Now instead of writing this operation in a separate class, in runnable interface operation, instead of writing in separate class, you can make anonymous in a class. For this, you can get thread very easily. Or this operation also, instead of writing this in this way, what I'll do is, so this is thread th is equal to new thread, by giving here new my thread, right? And you can just say here th dot start, right? Run it, it is also same, and output is still same, right? But again, instead of doing this, instead of implementing this runnable interface in a separate class, what I can do is, I can implement that by using a anonymous in a class. And how you're going to do it is, take a thread th is equal to new thread, and here only you say new runnable interface, and you create say anonymous class in this. So this is a runnable interface. This complete from here till this is a runnable interface object, and inside this you have to give the implementation. This is runnable. It is not a runnable object actually. It is becoming a anonymous in a class, and after that it gets an object of anonymous in a class type, and whatever implementation we have written in this run method, you just copy that and copy and paste here, right? The same thing. And actually th1 is already there, so I'll make it th1 and this is actually not required, so this is done. Now instead of giving a separate class implementation for this, we have given here itself, and this is done. Sorry, it has to give it right. It is giving an error, new runnable of from here, the anonymous class starts, and you have to give run method starts from here of this class, and run method is we have missed one, and right. So this is the implementation. Instead of giving the implementation in a separate class, you give the implementation inside the thread constructor itself. The complete implementation of the runnable interface inside the thread constructor, instead of giving it here, right? Instead of giving it here, I have given at this point. And now it is creating an object of type anonymous type for runnable type, which is subtype, and that object is going to use here inside the thread like this, or it is this, right? Now I'll not run this, I'll start directly this one. And okay, after that you have to say here start, it is th1 dot start, right? And run it, it is started. Still it is the same output. So this is the use of anonymous class. Actually you no need to implement a separate class for this, and you can use it in this way instead of implementing this in a separate place. And you can instead of creating objects separately somewhere, or you are getting it here, you just use at this place directly, right? So this is anonymous in a class, and what are the members you can define anonymous in a class, and how newly defined variables, how newly defined methods will work in the anonymous in a class, and how you can use a runnable interface in that separately runnable implementation, how you can give, and how you can give the implementation inside the thread constructor itself, right? And how you can start the thread, right? So this is anonymous in a class. Thanks for watching my video, and please subscribe for more videos.